Let's talk about the next core object in Python, and that is lists. So where strings were sequence of individual characters, lists are sequential items. So instead of just one string or whatever, lists are a collection, or a list is a collection of sequential objects. So let's take a look. All right, here's a couple example of your basic list. As I said, a list is a collection of various objects. Now, to make a list, as you can see, the syntax is open and close brackets. So, for example, we have things in my room. That might include a dresser, bed, window, clothing, and nightstand. We have the recipe for a basic spaghetti dinner. It could be ragu or rouse, whatever is, or prego. Plus, we have the cheese. You might want to flavor it with pork and, of course, your spices. If you don't put enough spices in it, then it's nothing more than ketchup, or tastes nothing more like ketchup. Now, here with the bowling scores, here we have a bunch of integers, but I did want to point out that it does support having two of the same items right here. So it's a copy of one another. It's the same thing with strings, of course. For example, just the very fact that you can have a string called spaghetti, and just the very fact that you have two T's in a row means it does support non-unique things. So that was a big deal about this. Now, employee profiles. I did want to indicate that there is a way to put a list within a list. So we have this employee profile. We have Jim Reichs, and his employee number is this. And I did want to indicate that we have this list within a list, but yet we have a string item here, and we have an integer item here. It does also support other data types, such as the float or the double. In the case of Python, they call it the double. And it supports complex numbers. But that being said, we have here a string, but we also have a integer, and we have another string, and we have this list, and we have these two lists that are in fact separated by a comma, and we have here another list, another profile for an employee, plus we have this third profile right here, and I just put just for spacing concerns, I just put employee 45, and you just have to make sure with that last list we have close bracket, and then you have to close the final bracket for like the entire list. So it's a little bit like a sandwich. So you have your initial slice of bread here, and then you have to close it out with your slice of bread here. Here it's almost like a matrix in which you have a list within a list. Finally, one of the advantages that lists have over strings, other than the fact that it's a collection, a list represents a collection of objects or items, whereas a list is a sequence of singular characters, which as a whole comprises only one item. A list does support item assignment. So let's take a look here. Then this is, of course, a comment right here. Let's say you wanted to remove pork, and you wanted to replace it with ground round or ground chuck. So what we do is we can say spaghetti, and then we indicate where index-wise this item is. So that's 0, 1, 2. So that's the second item index-wise. And then we can say we don't want pork, we want ground chuck, 80-20. And we can press enter. And let's go ahead and print spaghetti. And now we have ragu cheese, ground chuck. All right, let's take a look at this bowling score right here. Let's go ahead and let's increase this one right here, this 80. So in other words, I did want to indicate that it does see a difference between this 80 because it corresponds to another position index-wise. So this corresponds to the 0, 1, 2, third item, third offset, and this one corresponds to 4, 5, the sixth offset. So let's go ahead and improve the score to this offset. So where did I say 6? So bowling scores 6, and we can use the same notation as before, plus equals, and let's give them a couple more spares, maybe a couple more marks. Let's give them 30. So let's go ahead and print bowling scores, and so now we can see that the 80 has become 110, and it is able to differentiate the sixth offset as opposed to the third offset, which is this one. As you can see, the 80 is still the same. Now let's see what actual methods we have available to us. So for example, let's do things in my room dot, and we have the methods that we have in here include append, insert, remove, and whatnot. So let's go ahead and let's append, and we can see that this open parentheses doesn't have a close parentheses, so that means it needs at least one parameter. And of course, the parameter is what do we want to append for things in my room. So let's say also in my room is, I don't know, a closet. So let me press enter. Now let's print things in my room, and it does add closet. Notice when we utilize the append method, it puts it explicitly at the end. So you might see a difference a similarity between append and insert. With insert, we actually can specify the location where we want it. Okay, let's focus on the insert method. So let's get to our method so we can say the actual structure name or list name, list1 dot, and then press tab twice, and there is the insert method right there. And we can say insert, and we first select the position. We'll say position 2, offset 2, and what exactly do we want to put there? And we'll just put the string value pi right here, and press enter. And let's take a look at what list1 is, and we can see that it put it in the second offset position, 0, 1, 2. And if we wanted to replace that, we could say list1 dot list1 and then offset 2 using the index syntax notation, and then we can say something like 3.1416. And notice we aren't putting the integer value, we are putting the string value, just for me to show you that a list can support both integers and strings, and it can also we can just append another type, a type we haven't even just talked about yet, and that is the double. So we can append 34.20 right here, just to show you that we can append and we can modify this list and insert all kinds of data within the same list. So that's one of the aspects of lists versus, say, arrays in other languages. Arrays do not support dynamic item assignment like lists do, and they don't support using other types of data within the same data structure.